All right, well, guess we'll get started here in a moment. Okay. So we have been going over functions, started with graphs of functions, moved on to looking at the actual algebra underneath those functions, what all that looks like, and coming around to inverses, what we've recently been working on. This is going to be our last day on inverses. And what we want to do now is check to see, is there an easy way to tell if a function even has an inverse or not? So this is something that is not terribly involved, but it is important because there's not really any desire or requirement to waste time trying to find an inverse if you can determine that it doesn't even exist. Okay, so let's go back to the start of functions. Let's see what it means to be a function. Okay. So is this blue line a function? What's the test to be able to find if something is a function or not?
Vertical line test.
The vertical line test, exactly right. So if you can take a vertical line and move it along the graph, that line better only intersect that in one place. Or I guess it cannot intersect in more than one place. It could intersect 0 places, that's fine, but it can't intersect 2 or more places. So an example of not a function would be something like this. No, sorry, this is a function. I meant to draw it the other way. So this is not a function, because if we put our line up there, it intersects that red line a bunch of places. So the way you tell if a function exists is if it passes this vertical line test. Okay, pretty good, straightforward. What about an inverse? Graphically, what does an inverse of a function do? So if this is f of x, then what does the inverse of that look like? Graphically, what does taking the inverse do? What happens when you take the inverse of a function? How about graphically or algebraically? How do you take the inverse, period?
Isn't it basically the same thing, just reversed?
What do you mean reverse?
Like if it's positive, it'll be like negative. So therefore, like,
so that's the another thing in the same family. So that's not an inverse. That's a reflection over an axis, but it's close. it's related to it. So if you reflect over the x-axis, then you make all of the y values negative of what they were. Or if they were negative, then you make them positive. Same thing with a reflection over the y-axis, you make all the x values opposite of whatever they were. But this inverse is we said was a kind of a special kind of reflection. What axis does the inverse reflect over? So what do you do to the algebraically, what do you do for an inverse? See if we can figure it out that way. What do you have to do to the equation to find the inverse of a function? Remember, it's close to those reflections, but it's a little bit different. So what was the other one in that same family? Come on, this is important. Didn't think this was going to be the struggle part today. What does it mean when you take the inverse of a function? So let's say our function is y equals x plus 5. What is the inverse of that function?
Y equals x minus 5.
X minus 5. Okay, so what about y equals 2 times x?
Y equals 2 divided by x.
Other way around. So the way you find an inverse is you take your original equation and you switch the y and the x. And then you solve for y. So if we switch these two, we get x equals y plus 5. But we want the y to be by itself, so we move the plus 5 over. So we get x minus 5 equals y. Same thing over here. We switch these two and then get y by itself again. You have to take the 2 and divide it over. So you get y equals x divided by 2. We said that switching the y and the x was like taking this thing and moving it there, and this one moving it there. The same thing with these two. We swap these two. What this does is it is a reflection over this axis. So axis is so f of x is the blue one, and the green one looks something like obviously my skills aren't great, but it's this thing pointed that way. Okay. So my question is the green one a function?
No,
Why not?
because when you do the vertical line test, it crosses over more than once.
Exactly right. So it does not pass the vertical line test. So it is not a function. Okay. Is there a way we could have figured this out before we found the inverse? So let me ask a slightly different way. The vertical line test, every vertical line has an equation to it. Let's say we have a vertical line, I don't know, right here, and it crosses at 5. Then that dotted line has the equation x equals 5. But what is the inverse of this equation? How do you find the inverse of an equation? Y'all making Delvin carry the class here. Let's get some more opinions. Unless y'all are just I don't know, away from the keyboard.
Would it be just -5?
No. So what do you do when you take the inverse of a function? We said a second ago there's a process. It's really only 2 steps. And this one you don't even need the second step. when we had y equals x plus 5, to find the inverse, what did we do?
Did the opposite.
It ended up looking like the opposite of that, but because of the first step, well, I guess because of both steps. But what's the first step?
Is it to cancel x out?
It's not canceling x, but you are going to do something to x and to y. So remember, an inverse takes, a function takes an input, x, and gives you an output, y. The inverse of that function would take as its input y and give you back x. So
would it be 5 minus y?
no. So what we do is to find the inverse, we switch the y and the x. And then we resolve for y. So we want y by itself. So we take this plus 5 and subtract it over. Y equals x minus 5. So the first step is switch x's and y's. If you see an x, put a y. You see a y, put an x. So what is the inverse of this equation? What's the first step? That I just said. Come on, what's the first step? It's the thing I just said a second ago.
You want to solve for I think y.
Before that, what's the first step going from here to here? What did I do to this thing to make it this thing?
What happened was that you switched the x and y positions, and you also switched the operation.
Well, going from here to here, I didn't switch the operation or anything yet. I just replaced all of the y's with an x and the x with a y. So do that first step to this. And what do you get?
5 equals x.
No.
No.
The first step is y goes to x and x becomes y. Do that to this. Everywhere you see a y right here, put x. Okay? Good? Now everywhere you see an x, put a y. And tell me what you have.
Y equals 5.
Y equals 5. So the inverse of the vertical line test, actually, let's do this in a different color. The inverse of a vertical line test is a horizontal line test. So the way you determine whether or not a function has an inverse is if that function passes a horizontal line test. All right. So writing that out, so the way you tell if a graph or if a function has an inverse is just a horizontal line test. So if we do our example we were using without all the extra junk in there, this is our function. So to see if it has an inverse, we take a horizontal line. We see if it passes the horizontal line test. And it does not, because this ruler intersects the line at 2 or more places. So because it fails the horizontal line test, it does not have an inverse. So long way to go for minimal payoff, I'm sorry. But understanding how to do an inverse is very important. So it absolutely will be on the test and on the final, because it's not a terribly involved process, but it is a pretty important one. So yeah, please try and do some practice with that. If you need any extra help, and as always, just come to my office hours. I'm happy to try and walk you through. But there are some good sections in the book about these inverses of functions and stuff like that. So, like I said, highly suggest working on it. Okay. So, guess we will dip our toe into what our next little bit is going to be. And then we will finish it up on Friday. All right. So we're going to talk about the next level of functions and some qualities about them. So far, we've talked about f of x equals c, which is just a constant function. They're not terribly interesting, but it's just f of x equals some constant number. And we talked a good bit about linear functions. So these are just the equation of a line, nothing too crazy about those. And so kind of last, we're going to talk about which is either a squaring function or sometimes called a quadratic function. Okay. So this is one of the next examples of these basic polynomial functions, and this is of degree 2. So you could have a very simple version, like just f of x equals x squared. You could have something like we're a little bit more used to something like that. Really, anything with a highest degree on the x of 2 counts in this class of functions. But the most basic version is, or the parent function is just x squared. All right. So we'll just talk about some qualities before we get into any math of it. So one thing to look out for is you can have two main, I guess, visualizations of this thing. So let's start over a little bit. We'll start with the version most people are used to. So you have one version that looks like this, that most everyone has seen. Then you can also have one that looks like this. So what could cause, or what is the cause, the determining factor of whether or not you have one that opens up or opens down?
And it goes up.
Yeah, so what makes it open up or open down? So this is kind of a funny question, but we do have all of the tools that we need to answer it. This comes in terms of when we first started talking about functions. We started talking about even or odd functions. So what makes a function even? Or odd? So this is a quadratic is an example of an even function. But what is the thing that determines if it's even or odd? So the thing that determines the oddness or evenness of a function is the highest power in that polynomial. So this one has a highest power of 2, so it is even. But what determines graphically whether something is even or odd, how could you tell that this is even, that these are both even graphically? What was the way we said that you can tell that graphically?
Question.
I'm sorry?
Yeah, I have a question. So if it opens, or depending on how like it opens or how narrow it gets, is based on the even or odd of the exponent. What if it's an even and an odd at the same time?
Okay, what do you mean?
Like, what if it was x to the power of 4, and then another one that was x to the power of 3?
So the thing that makes it even or odd is the highest number. It's a very good question. The biggest one. So this one, the biggest exponent is squared, so it's even. If the highest exponent was a fifth, it doesn't matter if it's what else is in there. If the highest exponent is 5, it's odd. Highest exponent is 2, it's even. So probably gonna run out of time, but that's gonna be the quiz. We'll do that for a quiz at the start of Friday. Is what does it graphically make something even or odd? That's all we've got time for today, and I guess I will see you guys bright and early Friday morning. So I'll have a